what if that isn't true? What if ancient civilizations developed technologies far ahead of their time? Technologies that appeared thousands of years too early to exist. Some of these discoveries still leave scientists searching for answers. And once you see them, history may never look the same again. Long before the modern world learned to harness electricity, compute complex mathematics, or engineer precision machines, ancient civilizations were already experimenting with technologies that seem wildly out of place in their time. Technologies that should not exist. Technologies that appear centuries, sometimes millennia, too early. Across deserts, jungles, oceans, and forgotten ruins, archaeologists have uncovered artifacts that defy the conventional timeline of human progress. Devices built with precision that rivals modern engineering. Knowledge encoded in stone, metal, and mechanism. Knowledge that later civilizations would lose, forget, or rediscover thousands of years later. Today, we explore 10 ancient technologies that appeared far ahead of their time. As you listen, remember this. History is written by survivors, not by inventors. And much of what humanity once knew has been erased, not by catastrophe alone, but by time, neglect, and fragility of knowledge itself. Our first technology forces us to confront an uncomfortable truth about ancient intelligence, one that modern science is still struggling to explain. Hidden for nearly 2,000 years beneath the debris of a shipwreck off the coast of Greece, a corroded mass of bronze fragments was recovered in 1901. At first, it appeared unremarkable, just another relic from the ancient world. But as researchers carefully cleaned and examined the fragments, they realized they had found something impossible. Inside the corrosion were gears, dozens of them, interlocking, precisely cut, and arranged with mathematical intent. This object would later become known as the Antikythera mechanism. At a glance, it looks like a crude assembly of bronze plates and wheels. But when reconstructed, the mechanism reveals itself as a machine of staggering complexity, one capable of predicting astronomical events with extraordinary accuracy. It tracked the movements of the sun, the moon, and possibly the planets. It could predict eclipses decades in advance. It modeled lunar cycles with a precision that would not be matched again until the invention of mechanical clocks in medieval Europe. Over 1,000 years later, the Antikythera mechanism was not a simple tool. It was an analog computer, built around 100 BC. To create it, ancient engineers had to understand differential gearing, complex ratios, and celestial mechanics, concepts that, according to conventional history, should not have existed yet. Even more unsettling is the realization that this device was not a prototype. It was too refined, which suggests something far more troubling, that it was part of a larger technological tradition that has been almost entirely lost. No blueprint survived, no instruction manuals, no written explanations detailed enough to explain how it was built. The knowledge vanished, and the Antikythera mechanism became a silent witness to a forgotten scientific revolution that never reached us. If ancient Greeks could build machines capable of modeling the cosmos, what else did they know? And why did that knowledge disappear? The second technology takes us even further back in time, into a civilization long dismissed as primitive. Ancient Egypt is often remembered for its monumental architecture, pyramids, temples, and colossal statues. But hidden within its art, tools, and construction methods is evidence of a level of precision that should not have been possible. Consider the stone vases found in the ruins of Egypt's earliest dynasties, carved from granite, diorite, and basalt, materials nearly as hard as modern industrial ceramics. These vessels exhibit internal symmetry and smoothness that challenge modern machining. The interiors are perfectly hollowed. The walls are uniformly thin. The curves are flawless. Modern engineers attempting to recreate them using hand tools fail consistently. Even with advanced lathes, achieving the same internal precision is extraordinarily difficult, which raises a disturbing question. How did ancient Egyptians shape stone with such accuracy, thousands of years before the invention of modern cutting tools? Evidence suggests the use of advanced drilling techniques, possibly employing tubular drills with abrasives capable of cutting to the hardest stone. Drill holes found in ancient sites show spiral grooves, marks consistent with high-speed rotational drilling. Some cores extracted from granite blocks display feed rates that modern engineers say should be impossible without powered machinery. And yet, these artifacts are real. They exist, and they predate iron tools, steel blades, and modern engineering by millennia. The implication is clear. Ancient Egyptians possess a level of material science and mechanical understanding that has been profoundly underestimated. This was not accidental craftsmanship. It was applied technology. Technology that would later vanish, leaving behind monuments no one could replicate at scale for thousands of years. As we move deeper into this list, a pattern begins to emerge. These technologies are not isolated anomalies. They are a fragment of something larger, a web of advanced knowledge scattered across ancient civilizations, each piece surviving by chance. And as we continue, the discoveries will only become more unsettling, because the next ancient technology suggests that long before modern maps, satellites, or global navigation, someone had already mapped the world with shocking accuracy. If you're fascinated by lost knowledge and forgotten civilizations, consider subscribing to Ages Past. This channel is dedicated to uncovering the parts of history most people never hear about. Long before the age of satellites, aerial surveys, or global navigation systems, ancient civilizations were already creating maps that suggest a view of the Earth from far above its surface. Our third technology comes from a document that should not exist in its level of accuracy. In 1513, an Ottoman admiral named Piri Reis compiled a world map based on much older sources. At first glance, it appears unremarkable, until scholars began to study it closely. The map shows coastlines of Africa and South America with astonishing precision. Mountain ranges are placed accurately. River systems align closely with what modern cartography confirms today. But the most troubling detail lies at the southern edge of the map. Beneath South America appears a landmass that strongly resembles Antarctica. Not Antarctica as we know it today, covered in miles of ice, but Antarctica without its ice sheet. Seismic surveys conducted in the 20th century revealed that the coastline beneath Antarctica's ice closely matches the shape depicted on the Piri Reis map. This presents a profound problem. Antarctica has been covered in ice for at least 6,000 years. So how can an ancient map depict it ice-free? Piri Reis himself stated that his map was compiled from much older sources, some dating back to the time of Alexander the Great, others far earlier. These source maps are now lost, which raises an unsettling possibility that an ancient civilization possessed the ability to survey the Earth from a vantage point we still cannot explain. Some scholars suggest advanced mathematics and long-term astronomical observation. Others speculate about lost seafaring civilizations with global reach. More controversial theories propose technologies long erased from history. What matters is this: the map's accuracy is real, and it should not exist according to our accepted timeline. The fourth technology pushes us into the realm of medicine, where ancient knowledge appears disturbingly advanced. In the ruins of ancient India, medical texts known as the Sushruta Samhita describe surgical procedures that sound unmistakably modern. These texts detail cataract surgery, cesarean sections, bone reconstruction, and even plastic surgery. Most astonishing of all is rhinoplasty, the surgical reconstruction of the nose. Using skin grafts, precise incisions, and detailed postoperative care, ancient surgeons were performing operations that European medicine would not master until the 18th century. The techniques described are not vague. They include step-by-step procedures, sterilization methods using heat and herbal antiseptics, and post-surgical recovery protocols. Even today, some principles of modern plastic surgery trace their origins directly back to these ancient methods. This was not primitive healing. It was a systematic clinical medicine, knowledge that survived only in fragments, passed down unevenly, while much of the ancient medical world disappeared into obscurity. The fifth technology comes from a place often overlooked in discussions of ancient innovation: the deserts of Mesopotamia. Thousands of years ago, long before modern chemistry, ancient craftsmen were producing materials that modern science only rediscovered recently. One such material is synthetic glass of exceptional purity. Artifacts from Mesopotamia show controlled coloration, uniform thickness, and optical clarity that suggests a deep understanding of heat control, chemical ratios, and material behavior. Even more remarkable is evidence of early batteries. Clay jars containing copper cylinders and iron rods have been found near Baghdad, dating back nearly 2,000 years. When filled with acidic liquids, these objects generate a small electrical charge. Today, they are known as the Baghdad batteries. Their exact purpose remains debated. Some suggest electroplating, an advanced technique that allows a thin layer of metal to coat another surface. Others propose medicinal or ritual uses involving mild electrical stimulation. What cannot be denied is this: they demonstrate an understanding of electricity long before its supposed discovery. And once again, the knowledge vanished. The sixth technology forces us to confront the idea that ancient builders understood structural engineering far better than we give them credit for. Across the ancient world, from Rome to South America, structures stand that have survived earthquakes, floods, and centuries of erosion. Roman concrete, in particular, has baffled modern engineers. Unlike modern concrete, which degrades over time, Roman concrete grows stronger with age. When exposed to seawater, chemical reactions within the material create crystalline structures that reinforce it from within. Modern scientists have only recently begun to understand how this works. The Romans did not have microscopes. They did not have chemical equations. Yet they engineered a building material superior in longevity to our own. Why was this knowledge lost? Why did later civilizations abandon it? The answer may lie not in ignorance, but in collapse. As empires fell, trade networks dissolved. Specialized knowledge disappeared with the craftsmen who held it. And so, humanity reinvented what it had once already known. The seventh technology brings us to South America, where massive stone blocks were shaped and fitted with impossible precision. At sites like Pumapunku and Sacsayhuaman, stones weighing dozens, sometimes hundreds, of tons are cut with razor-sharp edges and interlocked without mortar. The joints are so precise that a blade of grass cannot fit between them. Even today, replicating this level of precision on such massive stones will require heavy machinery and laser-guided tools. Yet these stones were shaped thousands of years ago. No tool marks explain how. No written records describe the method. All that remains are the stones themselves, silent, immovable, and utterly defying a conventional explanation. And as we approach the final three technologies, the implications grow even more profound, because the next discovery suggests that ancient civilizations may have understood the principles of automation long before the industrial age. We're only halfway through this journey. The discoveries ahead are even more difficult to explain, and some may completely change how you think about the ancient world. The eighth ancient technology brings us face to face with a concept we associate almost entirely with the modern world: automation. When we think of automated machines, we imagine factories, robotics, and digital control systems. But centuries before the Industrial Revolution, ancient engineers were already experimenting with self-operating devices. In the ancient city of Alexandria, a center of learning and innovation, lived an engineer named Hero, known today as Hero of Alexandria. Hero described machines that could operate without human intervention, doors that opened automatically when a fire was lit on an altar, statues that poured wine when a lever was pulled, theatrical displays powered entirely by hidden systems of weights, pulleys, steam, and pressure. One of his most famous inventions was the Aeolipile, a steam-powered device that rotated when heated. It is often called the world's first steam engine, built nearly 2,000 years before the Industrial Revolution. Hero's machines were not toys. They demonstrated an understanding of pneumatics, hydraulics, pressure differentials, and mechanical feedback systems. The principles were there. What was missing was not knowledge, but continuity. These technologies remain curiosities, confined to temples and demonstrations, rather than transformed into widespread industrial tools. When Alexandria declined, so too did the transmission of this knowledge. Automation vanished from history, only to be rediscovered centuries later. The ninth technology forces us to reconsider humanity's relationship with optics and light. In ancient Mesopotamia, archaeologists discovered a small, polished crystal lens dated to around 750 BC. Known today as a Nimrud lens, it magnifies objects several times when held correctly. At first, scholars dismissed it as decorative, but further study revealed optical properties consistent with a functional magnifying lens. Similar lenses have been found in ancient Greece and Rome, which raises a startling question. Were ancient civilizations using optical tools? If so, for what purpose? Some researchers suggest craftsmanship, engraving fine details into metal or stone. Others propose medical applications, or even early astronomical observation. There are ancient texts describing stars appearing larger, clearer, and more numerous than expected with the naked eye, if lenses were in use. This would push the development of optical science back more than 1,000 years earlier than previously believed. And once again, the pattern repeats. The knowledge existed, the artifact survived, but the context was lost. Our 10th and final technology may be the most unsettling of all, because it suggests that ancient civilizations understood time itself with astonishing precision. Across the ancient world, massive stone structures aligned perfectly with celestial events. Stonehenge marks solstices with remarkable accuracy. Mayan observatories tracked planetary cycles. Egyptian temples align with stars that rise only on specific days of the year. These are not coincidences. They require generations of observation, precise measurement, and mathematical modeling. Some ancient calendars were so accurate that they deviate from the modern calendar by mere seconds per year. The Maya calculated the solar year to within a fraction of a minute, without telescopes, clocks, or modern instruments. Their understanding of time was cyclical, predictive, and deeply integrated into architecture, agriculture, and ritual life. This was not primitive stargazing. It was applied astronomical science. Science that shaped civilizations and then vanished. As we step back and look at all 10 technologies together, a powerful narrative emerges. Ancient civilizations were not technologically stagnant. They experimented. They innovated. They solved complex problems using observation, mathematics, and engineering. But their knowledge was fragile. Unlike digital data, it lived in people, craftsmen, engineers, scholars. When societies collapsed, knowledge collapsed with them. What survives today are fragments, artifacts without manuals, machines without blueprints, structures without explanations. And yet, those fragments are enough to tell us something profound. Human progress is not a straight line. It rises, it falls, and sometimes it forgets what it once knew. The ancient world was not waiting for modern civilization to begin thinking. It was already thinking, already building, already understanding. And as we continue to uncover these technologies, one truth becomes impossible to ignore. The past is not behind us. It is beneath us, waiting to be rediscovered. If this journey through lost ancient technology has challenged the way you see history, stay curious, because there are still countless discoveries buried beneath the earth, each one capable of rewriting what we think we know about our own origins. And somewhere, beneath layers of time and silence, the next impossible technology is still waiting to be found. If you're enjoying this deep dive into ancient technology, subscribing helps ensure you don't miss future documentaries exploring lost civilizations and unexplained history. Yet even after examining these 10 technologies, the story is far from complete, because for every artifact we have uncovered, thousands more remain buried, eroded by time, hidden beneath cities, oceans and deserts, or lost forever catastrophes we barely remember. What we call ancient technology is often judged through a modern lens that assumes linear progress. Stone tools lead to bronze. Bronze leads to iron. Iron leads to machines. Machines lead to computers. But the evidence refuses to follow that neat narrative. Instead, it suggests something far more complex. Knowledge did not simply accumulate. It concentrated. It emerged in specific places, flourished under unique conditions, and depended on fragile chains of human transmission. When those chains broke, entire sciences vanished. Consider this. A single generation without teachers is enough to erase centuries of expertise. A single war can silence a city of engineers. A single collapse can reset technological progress back to its foundations. This is why ancient technologies feel so unsettling. Not because they are impossible, but because they remind us how easily intelligence can be lost. Many of these early innovations were never meant to scale. They were designed for elites, priests, scholars, or specialized craftsmen. Knowledge was guarded, encoded in symbolism, passed orally, or restricted by class. When those guardians disappeared, The knowledge disappeared with them, and what survived were only the results. Machines without instructions, buildings without blueprints, artifacts without context. Take a moment to imagine how many inventions never survived at all. How many devices were made of wood, leather, fiber, or organic materials that decayed completely? How many technologies existed briefly, then vanished without leaving even a fragment behind? Archaeology is not a record of everything humanity achieved. It is a record of what happened to survive, which means our understanding of the past is shaped as much by accident as by truth. This realization forces us to confront a difficult idea, that our ancestors may not have been less intelligent, only differently organized. They observed nature obsessively. They tracked cycles over generations. They experimented slowly, carefully, and deliberately. They optimized designs over centuries rather than product cycles. Where modern society prioritizes speed, they prioritize endurance. Where we build to replace, they built to last. And sometimes they succeeded so well that their creations outlived the civilizations that made them. These 10 technologies are not evidence of a lost, advanced civilization in the sensational sense. They are evidence of something more subtle and more human, that intelligence arises wherever curiosity is allowed to persist. That innovation does not require electricity or silicon, only time, observation, and continuity. And that continuity is the rarest resource of all. As you reflect on these discoveries, consider this question. If modern civilization were to disappear tomorrow, what technologies would survive 10,000 years from now? What would future archaeologists find? A few concrete structures, some ceramics, perhaps traces of metal. But the most advanced knowledge we possess, our digital systems, our data, our sciences, would vanish almost entirely. Without power, without maintenance, without people, modern intelligence would evaporate. And future generations might look at the ruins of our world and underestimate us, just as we have underestimated the ancient past. This is why studying ancient technology matters, not to glorify mystery, but to understand fragility, because progress is not guaranteed. It must be maintained, taught, protected, and shared. The ancient world reminds us that brilliance is not rare. Preservation is. And as long as there are ruins beneath our feet, unanswered questions in the soil, and artifacts that do not fit the story we expect, history will remain unfinished. The next discovery could be buried beneath a farmer's field, or hidden beneath a city street, or waiting silently at the bottom of the ocean. And when it is uncovered, it may once again force us to rewrite what we think we know about technology, about intelligence, and about ourselves. The past is not done speaking. We are simply learning how to listen. And listening to the past requires patience. Because the deeper archaeologists dig, the clearer it becomes that what we call lost technology is not the result of a single forgotten age, but a repeating cycle that has defined human history again and again. Civilizations rise, accumulate knowledge, refine techniques, and push the boundaries of what is possible. Then something happens. Climate shifts, trade routes collapse, wars erupt, pandemics spread, power centralizes, knowledge fragments, and eventually entire systems fall apart. What survives is never the full picture. It is always incomplete. This is why so many ancient technologies feel isolated, appearing suddenly in the archaeological record, fully formed, with no obvious developmental path leading up to them. But development did happen. It simply didn't survive. The Antikythera mechanism did not emerge from nowhere. It was a product of generations of astronomical observation and mechanical experimentation. Roman concrete was not invented overnight. It was refined slowly through trial, error, and accumulated experience. Ancient surgical techniques were not improvised. They were taught, practiced, and improved over centuries. Yet, when the social structures that supported this knowledge collapsed, the knowledge itself vanished. Libraries burned. Workshops were abandoned. Apprentices were never trained. And so history reset. Again and again. This realization challenges one of the most deeply held assumptions of modern thinking, that we are inevitably smarter than those who came before us. But intelligence does not accumulate automatically. It must be transmitted. And transmission is fragile. Ancient societies understood this instinctively. That is why so much knowledge was encoded in myth, ritual, architecture, and symbol. When writing was rare or restricted, memory became the archive, buildings became textbooks. Alignments, proportions, and patterns preserved information without words. Stone was the hard drive of the ancient world, and sometimes it still speaks. Look closely at ancient structures and artifacts, and you begin to see recurring ratios, harmonies, and mathematical relationships. The same geometric principles appear in Egypt, Mesopotamia, India, Mesoamerica, and Greece. Cultures separated by vast distances and time. This does not mean they shared a single origin. It means they shared the same curiosity. They asked the same questions. How does the sky move? How does matter behave? How can forces be controlled, measured, repeated? And they answered those questions with the tools they had. Slowly, carefully, patiently. The technologies we've explored were not accidents. They were solutions, built to solve real problems. Tracking time to predict floods and harvests. Engineering materials to build structures that would endure. Developing medical techniques to heal injury and extend life. Creating machines to reduce labor, automate tasks, and impose order on complexity. These goals are not modern. They are human. And when we frame ancient technology this way, something remarkable happens. The mystery does not disappear, but becomes grounded. The past stops feeling alien and starts feeling familiar, which leads to a final, sobering thought. If ancient civilizations could achieve so much and still lose it, what does that say about us? Our technologies are more powerful, more interconnected, and more complex than anything the ancient world ever produced. But they are also more dependent on continuous infrastructure, energy, and stability. Remove electricity, and most modern knowledge becomes inaccessible. Remove networks, and information fragments instantly. Remove specialists, and systems fail rapidly. We live at the peak of accumulated knowledge, but also at its most fragile. The ancient world did not fail because it lacked intelligence. It failed because it could not protect continuity. And that lesson matters now more than ever, because somewhere in the ruins of the future, someone may one day uncover fragments of our civilization, objects at work, but whose purpose is unclear, machines that function but cannot be replicated, records that survive but lack context, and they may ask the same questions we ask today. How did they do this? Why was this knowledge lost? Were they more advanced than we think? The answer will be the same. They were human, curious, creative, brilliant, and vulnerable to forgetting. The story of ancient technology is not a story about mystery alone. It is a warning, a reminder that progress is not permanent, that knowledge must be carried forward deliberately, and that the past, far from being primitive, may be one of the greatest teachers we have, because it shows us not just what humanity can achieve, but how easily it can lose everything it once knew. And when we truly absorb that lesson, the ancient world stops feeling like a collection of curiosities and starts to feel like a mirror, because the technologies we've explored are not impressive simply because they are old. They are impressive because they emerged under conditions far more limited than our own, yet achieved results that still challenge modern understanding. No electricity, no computers, no global communication, only observation, memory, experimentation, and time. Time measured not in deadlines, but in generations. Ancient engineers did not rush innovation. They refined it. They watched how materials behaved over decades. They learned from failure without discarding the entire system. They optimized designs slowly, patiently, until they worked so well that no one felt the need to change them. That patience is visible everywhere. In stones cut to tolerances tighter than modern construction standards. In calendars calibrated over centuries of sky watching. In machines balanced so precisely they could run smoothly without constant adjustment. These were not the products of sudden genius. They were the outcome of sustained attention. And sustained attention is rare. Even today, as we push deeper into the archaeological record, one truth becomes increasingly clear. The ancient world did not lack innovation. It lacked resilience against disruption. When knowledge is centralized, held by a small group of specialists, it becomes extraordinarily powerful, but also extraordinarily fragile. When that group is lost, knowledge does not simply disperse. It collapses. This is why entire technologies can disappear so completely that later civilizations have no idea they ever existed. Not because they were secret, but because they were human. They lived in people, not in systems designed to survive catastrophe. This is why the ancient world feels haunted, because we keep encountering evidence of brilliance without descendants, ideas without heirs, technologies without continuity. And each discovery forces us to confront the same uncomfortable question. What else have we lost? How many inventions existed briefly, solving real problems, only to vanish without leaving a trace? How many ancient cities were centers of learning whose libraries, workshops, and laboratories were erased by fire, flood, or conquest? How many sciences were practiced long enough to matter, but not long enough to survive? The archaeological record is not silent on this. It whispers in anomalies, in artifacts that don't fit, in structures that should not stand. And those whispers grow louder with every excavation. What we call out-of-place technology is often simply technology out of context. Context that time has stripped away. This understanding reframes the mystery. The question is no longer, how could they do this? The question becomes, why did we forget? And that question is far more unsettling, because forgetting is not a flaw of the ancient world. It is a constant in human history. The loss of ancient technology is not an exception. It is the rule and progress. The kind we imagine as inevitable is the rare anomaly, which brings us back to the present moment. We stand at a point in history where knowledge has never been more abundant, more interconnected, or more powerful. But it has also never been more dependent on systems that require constant maintenance. We assume our advancements are permanent. The ancient world assumed the same. They carved their knowledge into stone. We encode ours into electrons. Both can vanish. And when they do, the future will inherit fragments, just as we did. Fragments at work, but cannot be explained. Fragments that hint at sophistication, but lack narrative. Fragments that invite speculation, wonder, and disbelief. And somewhere, centuries from now, a future historian may look at the ruins of our civilization and say the same thing we say today. They were far more advanced than we realized. The past is not a straight line leading to us. It is a vast landscape of peaks and collapses, brilliance and silence, memory and loss. And ancient technologies, those impossible machines, those precise stones, those forgotten sciences, are the peaks we can still see. They remind us that intelligence is ancient, that innovation is human, and that forgetting is our greatest weakness. The question is not whether humanity can build wonders. The ancient world answered that long ago. The question is whether we can remember them long enough to pass them on. Because somewhere beneath the ground, beneath the sea, or beneath layers of history we have yet to uncover, there are still answers waiting. And every time we uncover one, the past leans forward and asks us a final, quiet question. What will you leave behind? And will it survive long enough to be understood? And perhaps that is the most important realization of all. That history is not simply a record of what happened, but a record of what endured. Everything else, no matter how brilliant, how transformative, how revolutionary, simply disappears. When we look at ancient technology through this lens, the mystery shifts again. It is no longer about lost machines alone. It is about lost systems of thinking, lost cultures of learning, lost ways of teaching, preserving, and transmitting knowledge across time. Ancient civilizations did not separate science from philosophy, engineering from spirituality, or technology from meaning. Their innovations were embedded in daily life, ritual, and worldview. Machines were not just tools. They were expressions of understanding of cycles, of balance, of cause and effect. This integration made ancient technology powerful, but also made it vulnerable. When belief systems collapsed, when rituals ended, when societies fractured, the technologies bound to them often lost their purpose. A machine without meaning becomes scrap. A technique without tradition becomes forgotten. And a science without students vanishes silently. This is why so many ancient technologies appear suddenly in the archaeological record and then disappear just as abruptly. They were not mass-produced. They were cultivated. They required patience, discipline, and continuity. And continuity is fragile. The modern world often assumes that advancement comes from acceleration, faster tools, faster communication, faster innovation. But the ancient world teaches a different lesson, that some knowledge only emerges slowly, that some technologies require centuries of refinement, and that once lost, such knowledge is almost impossible to recover fully. We can study artifacts. We can reverse engineer fragments. We can model and simulate. But we cannot recreate the lived experience of the people who built them. We cannot recover the intuition passed from master to apprentice. The small adjustments never written down. The mistakes that taught lessons more valuable than success. Those things die with people. And that is why ancient technologies still humble us. Not because they are magical, but because they're human. They remind us that intelligence does not belong to any era. It belongs to conditions that allow curiosity to persist, knowledge to be shared, and experience to accumulate. When those conditions disappear, intelligence fragments, and history resets. This is a hidden story beneath every ancient machine, every impossible structure, every artifact that feels out of place in time. It is not evidence of lost superhumans. It is evidence of lost continuity. As we bring this journey to its final reflection, one truth stands above all others. The ancient world was not waiting for modern civilization to invent intelligence. It already had it. What it lacked was a guarantee of survival. And perhaps that is the greatest warning these technologies offer us. That no matter how advanced a civilization becomes, no matter how sophisticated its tools, no matter how vast its knowledge, none of it is permanent unless it is protected, taught, and passed forward deliberately. The past is filled with reminders of this truth, carved into stone, cast in bronze, buried in sand. And every discovery whispers the same message across time. Progress is fragile. Memory is precious. And the greatest technology humanity has ever possessed is not a machine. It is the ability to remember. History holds far more secrets than we're taught. If you want to continue exploring lost technologies, forgotten empires, and mysteries buried beneath time, subscribe to Ages Past and turn on notifications. The past is not done speaking.